Okay, what we're going to do here is we're going to start simplifying radical expressions with more than just a square root. The idea is the same, and we saw this in a previous video. If I'm looking for a cube root, so we got a cube root right here, I'm looking for sets of 3 that are the same. So I'm actually going to do a little bit of side work, and x to the 7th is going to be x times x, right? And we're going to do this 7 times. So we got 7 up here. So that means I'm going to look for groups of 3. So then that means I would take out an x, take out an x, and then I'd have 1 left over because this guy doesn't have, it's not a group of 3, it's only a group of 1. So that'd be x squared times the cube root of x. Okay, so that's actually how that would simplify. But what I want you to look at is, I want you to look at the radical value and the number 7. And if we think about it this way, 3 goes into 7 how many times? 2 times. Notice what my power is on the outside of the radical. It's a square. Well, how many is left over? 1. So how many is left over on the inside? 1. So I think about division when I'm looking at my variables, and that's a quick way to go through your radicals and simplify them. The numbers, we just have to think in terms of our factor trees. So -3 times -3 times -3. I got a group of 3 here, so I'm able to pull out a -3. This one is reduced. How many times does 3 go into 7? It goes in twice. So I have an x squared. I know I'm going to have an x left over, so I just cross out the 7. 3 goes into 3. 3 goes into 3 one time. So I can pull out 1y. There would be none left over. There's no remainder if I divide 3 by 3. So that gets crossed out. How many times does 3 go into 2? It doesn't go into 2, so I can't pull any z's out. So what I have left over was the x that was all by itself and the z squared. Okay, and that's how I would reduce a radical exponent greater than, working with a cube root or a 4th root, and that's how we would work with our variables.